Can a normal TV remote control a home AC light? In part 1, we controlled a DC LED. Today, I am extending the same circuit to control an AC light safely. In part 1, we built a remote control DC LED circuit using an IR sensor. If you haven't watched part 1, I highly recommend watching it first because today's video is a direct continuation of that circuit. That circuit works perfectly on low voltage DC. Now the question is, can the same control circuit be used for AC? In this video, I will show how to interface that same DC circuit with an AC light using few other components. And at the end of this video, there is a hint for the part 3 that every electronic enthusiast should know. So the required components are a control circuit which we have made in the previous video, IN4007 diode, BC547 transistor, 1 kilo ohm resistor, a remote, any TV or fan remote which has this IR transmitter, a 5 volts relay, a AC bulb and bulb holder, 230 volts power supply and also 5 volts DC power supply. Now let's place the components in the PCB board. Placing the components is done. Now let's start the connections. Connect the one end of resistor to positive terminal of LED and other end to base of transistor. Connect the collector terminal of transistor to positive terminal of diode. Connect the emitter terminal of transistor to pin number 8 of IC. Connect the negative terminal of diode to plus 5 volts. Connect the both terminals of diode to both terminals of relay. This is the same 5 volts relay which we have in our circuit. I am showing in such a way so that you can understand the connections more clearly. Connect the positive terminal of diode to one terminal of relay and connect the negative terminal of diode to the other terminal of relay. Now take this middle pin of relay as positive wire of AC and the other pin of relay as negative wire of AC. Leave this terminal without any connections. Connect the 5 volts input power supply to these 5 volts input terminals. Here I am providing input power supply through the help of a 5 volts adapter. You can also use 5 volts battery. Now take a AC bulb along with the holder, cut the live wire and connect the two ends to the two terminals of relay. Apply the tape as a safety precaution. Now let's check the working of the circuit. As we all know, the first 4 times the circuit won't work. After pressing button for 4 to 5 times, the circuit starts working. You can see the circuit is working perfectly. You can hear the clicking sound when I press the button. That clicking sound you hear is the relay switching on and off. Now let's see how this circuit works. When I press a button on the remote, it sends an IR signal. The IR sensor receives it and triggers the control circuit. Here, the main role is played by the relay while working with the AC load. A relay is an electrically operated switch. A relay allows a low voltage DC control circuit to safely switch a high voltage AC light. It provides electrical isolation so the AC supply never comes in contact with the DC control circuit. In short, we can say a relay acts as a safe bridge between DC control and AC load. Here, the signal from the control circuit energizes the relay coil. When the relay is energized, it mechanically switches the AC circuit. So finally, the AC light turns on without AC ever entering the control circuit. Here, the transistor amplifies the weak signal from control circuit. The diode is used for protection. This diode acts as a flyback diode or freewheeling diode. Generally, a relay coil is an inductor. When we turn off the relay, the magnetic field around the coil collapses suddenly. This creates a high reverse voltage spike, back EMF. That spike can damage the transistors, ICs, and other components present in the circuit. Hence, a diode is connected in reverse bias during normal operation, so it does nothing when relay is on. When the relay is turned off and a high voltage spike appears, the diode becomes forward biased. It provides a safe path for current to circulate. The spike is reduced, clamped to lower voltage. Hence, our circuit is protected. In short, we can say the diode across the relay protects the circuit by absorbing the high voltage produced when the relay turns off. If you have come this far, then congratulations. It shows you are really serious about learning electronics. In the next video, I will explain some of the most common mistakes made while building electronic projects. If you want to move one step ahead in electronics, don't miss it. If you find this video helpful, like the video and subscribe to our channel for more interesting and exciting projects.